You've heard the phrase a million times, natural selection. But what if I told you that this simple recipe we all learn in school has a hidden logical glitch, a real puzzle that nearly brought the whole theory crashing down? Today, we're going to unpack that.
We tend to think of evolution as this pretty straightforward process. And for ages, biologists have used what looks like a super simple three-step recipe to explain it. But is it really that simple? Let's take a look at the ingredients.
Okay, so here we go. This modern recipe, which was famously summed up by the geneticist Richard Lewontin back in the 70s, really tries to boil down Darwin's huge, sprawling idea into just 3 clean, elegant conditions. And, on the surface, it looks like it explains everything.
It's this really powerful if-then kind of statement. Basically, if you've got variation in a population, if those traits can be passed down, and if those traits actually make a difference in who succeeds, then evolution by natural selection has to happen. It's like a rule of logic. It feels totally undeniable, right? And this abstract recipe is actually a huge shift from how Darwin originally talked about it, with his whole narrative of a battle for life. Lewontin's version just strips all that away, down to the bare logic. But the really big change, the one that causes all the problems, is that it puts heredity right there as a main ingredient and shines this massive spotlight on the idea of fitness. And yeah, that's where the trouble really starts. Because by putting fitness on a pedestal like that, this supposedly perfect recipe cracks open the door to this huge philosophical puzzle. A puzzle so big, it threatened to make the whole theory of evolution totally meaningless. Which brings us right to our next section, the survival tautology problem. So what happens when a scientific explanation just goes in a circle, when it basically just repeats itself? Well, that's the tricky logical loop that haunted evolutionary theory for decades. Think about it. If fittest just means the ones who survive and have the most kids, then that grand old phrase, survival of the fittest, suddenly sounds a lot like the survival of the survivors. It's a circle. It doesn't actually explain why they survived. And that, my friends, is what you call a tautology. It's a statement that's true just because of how it's defined, but it tells you absolutely nothing new about the real world. It's like saying it is what it is. So if evolution is just the survivors survive, then it's not a scientific theory at all. It's just an empty phrase. So how on earth did biologists fix this? Well, the fix comes down to this really crucial distinction. Let's call it realized fitness versus propensity fitness. So realized fitness is what actually happened, the final score of the game. But propensity fitness is the tendency to succeed before the game even starts. It's the odds. Think of a coin. Its propensity is 50-50 to land heads. The realized outcome is that it landed heads. See the difference? Fitness isn't just a description of what happened. It's a probabilistic cause of what's likely to happen. All right, on to the next part. Selection versus random chance. And this whole distinction, this idea of a tendency versus the actual outcome, is super useful. Why? Because it lets us finally pull apart the two big forces that drive evolution, predictable advantages on one hand and just pure random luck on the other. And this is a great way to see the difference. Natural selection is when an organism does better because of its traits. The faster gazelle consistently gets away from the cheetah. That's selection. But then there's genetic drift. That's when things happen purely by chance. Imagine the 2 fastest gazelles in the herd get zapped by a random lightning strike. That had absolutely nothing to do with their speed. It was just bad luck. Okay, so we've debugged the recipe. Phew, it's not a tautology. But fixing that problem just opens up an even bigger, maybe even more profound question about what natural selection can actually do, which leads us right into our next section. Is it a filter or is it a creator? This is a really fundamental debate. Is natural selection just a negative thing, like a sieve that just weeds out the unfit? Or can it actually be a positive, creative force? Can it really build something as mind-blowingly complex as an eye or a human brain, basically from scratch? To get at that question, we need to split things in two. There's explaining where a new trait comes from in the first place. That's the origin explanation. And then there's explaining why it becomes common. That's the distribution explanation. Now, critics often say selection can only do the second thing. It can spread a trait around, sure, but it can't actually create it. But, and this is a huge but, seeing selection as just a filter totally misses its real power. The secret is that it's not just a sieve, it's an amplifier. So let's imagine you have a big population.
And in that whole group, maybe just 10 little organisms have some slightly useful new trait. Okay, now watch what the amplifier does. Fast forward 50 generations. Because that trait helps them succeed, selection doesn't just bump up the percentage a little bit. It can dramatically increase the actual absolute number of individuals with that trait. So you go from just 10 to maybe 10,000. And this is the secret sauce. Having 10,000 organisms with that trait instead of just 10 means you have 10,000 chances, 10,000 experiments for the next rare helpful mutation to pop up. It massively boosts the odds. And that's how a simple trait becomes the foundation for something way more complex. That is the creative power of selection. Which brings us to our final section, and this is where things get really wild. Darwinism beyond biology. Okay, so if this simple three-part recipe, variation, heredity, success, is so powerful, what happens if we try to apply it to things that aren't even alive? Now, even inside biology, this logic sparked a huge debate about the units of selection. Who's the main character in the evolutionary story? Is it the organism? Or, as people like Richard Dawkins famously argued, is it all about selfish genes that just use organisms like cars to drive themselves into the next generation? But there's a simpler, more modern view that says, hey, maybe we don't need to get hung up on who the main character is. Let's just use Lewontin's 3 conditions as a test. Take anything, a gene, a cell, an organism, whatever. Does it have variation? Can it be inherited? Does that variation affect success? If the answer is yes to all 3, then congratulations, it's a unit of selection. It's going to evolve. Simple as that. And this idea just explodes outside of biology. It's called Universal Darwinism, this mind-bending theory that maybe any system that adapts follows the same basic pattern of variation and selective retention. I mean, think about our own immune systems. They create millions of different antibodies, and only the ones that actually fight the infection get copied and amplified. Or think about science itself. We come up with tons of different ideas and then test them and get rid of the ones that don't work. Now, to be fair, the current thinking is a bit more nuanced. Maybe saying everything is Darwinian goes a little too far. A more moderate view is that, look, natural selection isn't the direct cause of everything. A better way to think about it might be that selection built the machinery, our brains, for example. But once that machinery is built, it can learn and create in totally new, non-Darwinian ways, like using planning and foresight, which is way faster than just random trial and error. And that leaves us with a really deep, final thought to chew on. If the very machinery of our minds, the thing that produces our art, our science, our creativity, if that machinery was itself built by a completely unthinking algorithmic process, what does that say about us? I think the big takeaway here is that natural selection is so much more than just a fact from a biology textbook. It's this incredibly profound and scalable pattern. Maybe, just maybe, it's the ultimate source code for all the complexity we see in the universe.